Hello. So we're gonna start off with chi distribution. So we have a problem here. Suppose that a sample of 10 ball pens has a population mean of 22 grams and a variance of 0.47 grams. What is the probability of the standard deviation is equal to 1? So first things first, we start off with the equation, which is s squared and mu squared. So we identified the sample is equal to 10 and the mean is equal to 220 grams. So first thing is we input what we have. So 10 minus 1 times s, we're going to use 1. So 1 squared all over the variance of 0.471. So we're gonna solve this. X squared is equal to 19.10828025. Now we're looking for the probability where s squared is equal to or greater than 1. So the probability of s squared is equal to or greater than 1 is also equal to the probability of this one here, the probability of the chi-squared. So we're just gonna input the variables here, the 19.10288025. Now we know that we have a degree of freedom n minus 1, which is also 9. So when you're going to look at your graph, you're going to have an answer, a probability that is equal to 0.025 or 2.5%. So we have a problem here, F distribution. Suppose you randomly select 7 women from a population of women and 12 men from a population of men. As you can see in the table that is given from the problem, women has 30 of standard deviation, population standard deviation, and men has 50, while the sample standard deviation is 35 over 45. Now we simply input in the equation that F is equal to 35 squared all over 30 squared, as you can see, all over S2 and population sample of 45. So 45 first on top and 50 at the bottom squared, which if you're gonna take your calculator, you're gonna have 1.68. So we also need to determine the calculation for the numerator of degrees of freedom. So V1 is equal to, again, look at the degrees of freedom, which is 7 for women, 7 minus 1, which is 6, and for men, which is V2, which has 12. 12 is equal to 12 minus 1 is equal to 11. Now we can get the population, the degrees of freedom in the given graphs. So in the given graphs, we can see that it has a probability of 0.595. I'm sorry, 1.595. The probability is equal to, in the given graph, which is 1.595, or the nearest one is 1.68, which is correctly the same to this one.